Hello, my name is Christopher Sanchez, and I will be talking about estimating regression parameters. This is usually done in the case that you want to find a correlation or a relationship between two or more variables in a test, or whether you want to find something out in your engineering field or study. So this is done via the two equations that are found on the slide. The first one being for mean of y given x would be represented by beta sub 0 plus beta sub 1x, and the second one being that same y equaling beta sub 0 plus beta sub 1x plus an error value. So the first one interacts much like slope-intercept form, which would be y equals mx plus b, where the beta sub 1x is equal to the mx, and then this b value would be beta sub 0. And beta sub 0 is the y-intercept and beta sub 1 is the slope. Then for the second equation, we see that the value of that e is random, this error value, so it could be interpreted as 0 if there is nothing found there. And to summarize that, it would be that beta sub 0 and beta sub 1x are parameters in this function, but beta sub 0 remains unchanged since it's not dependent on this x value. In this slide, we have an example given the two variables of average daily temperature and visitors in a water park. So we see that beta sub 0 would be the mean number of visitors for the temperatures ranging from 75 degrees to 95 degrees. And per 1 unit temperature change, we start to see a more positive trend of visitors coming. So it is easily likely to say that the higher the temperature, the higher amount of visitors. And through sample data, which is found here, these points, we can estimate the beta values. And it is safe to say, based on all these values, the mean would be 328 visitors per this whole range. Another way of estimating regression parameters would be via variance squared. Now we see in this section there is a line that has no given value, but there are 3 data points, and in each data point the variance is the same. Now we look at variance to see the variability of each data point in respect to the line that we have, and we create an estimate based on how far apart they are from the main data point that we find. And in the end, these values are estimated to find a good confidence interval for hypothesis testing procedures.